Have you ever looked up at the night sky and stared out to the stars and asked yourself the question, are we alone? I know I have. I am constantly looking up, mesmerized, and asking myself, we can't be the only ones, right? I mean, a universe covered in life would be amazing, and intelligent life would be on another level to that. But I think a universe with no other life at all would not only be kinda sad, but more astonishing than anything. The very fact that we are here and exist, and judging at how many other planets, stars, and galaxies there are, surely suggests that we can't be the only ones. So where is everyone then? The Fermi's paradox wonders why we haven't seen a shred of evidence of other life despite the overwhelming probability that it exists. What if there is something standing in life's way before it can achieve interstellar communication? If another more intelligent and advanced civilization could achieve this, then surely they would have tried to communicate with us. But this isn't the case, and the Great Filter Theory could be the reason as to why. This theory suggests without something getting in the way, planets within a hospitable star and Goldilocks zone, where it's not too hot nor too cold, should eventually give rise to life, which leads to tool-using animals with big brains, which eventually leads to interstellar communication. But seeing we haven't come across any other life at all, this might mean we're the only species to get past this stage, and the filter is yet to weed us out before we can make any more sophisticated technology for our quest to find life. The speed of light, as far as we know, is the cosmic speed limit. Light travels 300,000 kilometers a second or 186 miles per second. The closest we've come to traveling that fast was an unmanned probe called the Helios 2. It traveled at a speed of 250,000 kilometers per hour. Our closest neighboring star, Proxima Centauri, is about 4.2 light years away. That means traveling at 300,000 kilometers a second, it takes 4.2 years for the star's light to reach us. Let's use the Voyager 1 space probe as an example. Traveling at a constant velocity of 60,000 kilometers an hour, it would take around 76,000 years to reach the star. Or if it could somehow attain the speed of the Helios 2 space probe, it would take roughly 19,000 years, significantly better, but still a ridiculously long time. Some stars in the night sky are so far away, in fact, it takes the light from them billions of years to reach us. So perhaps the overwhelming size of the universe, combined with how hard it is to achieve the speed of light, could be why we are yet to come across other intelligent beings. Maybe unlike Earth, other planets don't have as many opportunities to harbor intelligent life. For example, around 65 million years ago, dinosaurs dominated the world and were uncontested for as long as 165 million years. During this time, our mammal ancestors were tiny rodents and were dwarfed by everything at the time. Things would stay much the same until an opportunity arose for these small creatures, and lucky for us, that was an asteroid which was roughly 10 kilometers across or 6 miles. It hit the planet and shot up debris and dust, engulfing the Earth, altering the climate. Blocking out the sun, plants weren't able to photosynthesize, plant-eating dinosaurs perished, and with it meat-eaters did too. The small nimble mammals were able to get by on what little was left. The asteroid wiped out the dinosaurs and gave our ancestors a chance to flourish and eventually evolve into the human race. Point being, if the asteroid never hit the Earth and the opportunity did not come to light, the planet may still be ruled by dinosaurs, and life in terms of intelligence would have plateaued until an external force hit the reset button. Throughout the history of life on Earth, there have been a total of 5 mass extinctions, the worst of which being 250 million years ago, where 96% of life was wiped out. This mass extinction early on in a planet's history may occur so often life can't get a proper foothold on the evolutionary tree to become a multicellular, yet alone a complex, intelligent being, capable of jet propulsion and communication. But what if, despite all that, an intelligent civilization did arise? They would then need to face a new obstacle and challenge. Let's use Earth and the human race as an example, because we're obviously living, breathing proof that that can in fact happen. The human race is faced with many problems that remind us that maybe we're not in the clear yet. We're at a fragile and difficult time in our history. Our technology has advanced so rapidly in the past 200 years, the planet hasn't had time to catch up. This technological adolescence could be another reason the universe is so quiet. Before a civilization can get to the stage of interstellar travel, they'd first need to traverse the problems we're faced with today, such as pollution, climate change, habitat loss, and nuclear war. Let's go into a bit more detail on at least one of those things I mentioned earlier, such as pollution. And one of the worst culprits of pollution is plastic. It's been around since the early 1900s, but wasn't popularized until the 1950s. Today, plastic has quickly become one of the most ubiquitous materials. It's cheap and easy to make, and most importantly, it stops moisture getting in or out. Earlier in our history, we had the Stone Age or the Bronze Age, to name a few, but in today's society, we're in a plastic age. 300 million tons of plastic is used every single year, but of that, only 15% is recycled. Plastics are made up of chain molecules, which are strung together. These chains are called polymers, and are made up of carbon and hydrogen, which derives from crude oil, natural gas, and a number of other materials. Plastic can stay intact for up to 1,000 years, before breaking down into countless tiny microplastic fragments, causing havoc on the natural world. Plastic surrounds us in our daily lives, and we've become so heavily reliant on it, it's hard to imagine life without it. The planet's oceans absorb around 8.8 million tons of plastic waste each year. In the Pacific Ocean alone, there are countless rubbish patches, the most popular being the Great Pacific Garbage Patch. At this stage, the patch has grown to twice the size than the state of Texas. These heaps aren't massive mountains of rubbish like you would imagine them to be. Instead, they are many small pieces congregated just below or above the surface of the sea, which make it extremely difficult to monitor by plane or by ship. The plastic pieces are in the open ocean, where the sun breaks down the polymer chains into smaller and smaller fragments, which are sometimes microscopic. They then get into the food chain, causing an array of new problems. There are currently 700 marine species threatened with extinction due to the risk of ingesting or becoming entangled in plastic waste. Seabirds, polar bears, turtles, and larger species like whale sharks and basking sharks, to name a few, are all at risk due to these plastic fragments. A study conducted by researchers at the Tokyo University of Agriculture and Technology revealed that 80% of anchovies found in the Tokyo Bay had been contaminated by microplastics. These fragments range from 0.1 and 1 millimeter in size and were found in their digestive system. In addition to all this, microplastics act as toxic sponges, absorbing a number of endocrine disrupting chemicals such as bisphenol A. When a marine creature consumes these chemical-ridden microplastics, humans then consume these animals, which then can have harmful effects on our bodies. Bisphenol A has been directly linked to certain types of cancer, fertility and birth defects, as well as neurological problems. It's vital that if we ever want to preserve the marine animals, the environment, and even our own health, we all need to take steps to minimize the amount of plastic we use in our everyday life. In the description, I've linked a few things to point you in the right direction and get you started.